know that there is a problem, but you don't know who you need to talk to, or you don't know how bad that problem is going to be in runtime. So that's the only thing that's going to stitch runtime with open source software library repo, and you have the likelihood that you're going to be able to say, hey, Mr. Team of Developer, go and fix that. It's the only way. At least for container, at least for if you're building your code, if you're building your cloud with infrastructure as a code, that is the future. Everybody's gonna build things in this way. So unless you start with this method, it's unlikely that you're gonna be able to say, hey, Mr. Dev team, fix this. And there are different methods, and there is different things to actually automate a whole lot of it. We have clients that have automated this so that they don't need to configure anything. The DevOps engineers self-declare the ownership of what they built with tags. We attribute things automatically with tagging, and we trace things automatically with our methodology. And they go confirm, deny. And we have different methodology. We have backstage methodology. We have different things to actually use the telemetry, the engineering, the DevOps, the other source of information to actually build this picture so that it becomes automated. And that's the trick, to actually pair up with engineering and use their tools to drive this picture, because this is how they build software. We as security professionals know absolutely nothing about this unless you build software, and it's unlikely that us or the new generation of AppSec folks knows how to build an application in a container, how to run it, how to, exactly.
But aren't some of the security things that have to be built in while you're building the software, and not be layered on top of that?
What do you mean?
Like certain, code that you have to make sure that you're compliant, or, that vulnerability and other stuff that you're baking into your code also.
It's important to actually scan code at this level, but if you don't know who owns that code, or who's their boss, how to enforce it, how to push down objective on them that matters to them, OKR or measurement that are not SLA. Because the first time you literally open an open source scanner in this area, it's gonna throw millions of vulnerability at you, or thousands of vulnerability at you. And you need to make the developer look like hero to say, hey, if you fix this one, the blast radius, the reduction of vulnerability might be massive. So they look good, you look good, security get implemented.
But when you're building code, there are certain applications like Sneak or other apps that actually do the scanning while you're, implementing your code.
Yeah.
So you don't have to do that at a later stage.
Everything that you build is going to become vulnerable at a certain point.
Mm-hmm.
So unless you build on an hourly basis, the likelihood that your Sneak will detect stuff that runs here is very unlikely. So your security tool like Wiz and other tools that speed up this information will fire up alerts that Sneak hasn't detected. But we can correlate those two things and say, hey, you have things here that appears here. So yes, there is tools, there is the advantage of actually building that in IDE, but things becomes vulnerable later on. Vulnerability get discovered, things get upgraded, not all the time Sneak can react faster enough or good enough. I'm not here to throw stone at Sneak.
I got a question.
Yes.
How do you go about coming up with the risk code for legacy code? Code written in the 90s and the 2000s. Since then, there's been a lot of migrations, a lot of improvements. Code written on one system, which was probably secure then, is probably insecure now, and it's live on a new system. And the worst part is, it's written by people who in the 1990s, might as well be ancient Greek.
Yeah, that's the problem of ownership. Like you write code and that code is not code anymore, but it's actually an application that is run